December 18, 1944. The Ardennes Forest, Belgium. Through swirling snow and artillery smoke, German Panther tanks advanced in what should have been perfect ambush conditions. Visibility, 200 yards. American forces, scattered and isolated by the surprise offensive. Wehrmacht doctrine said this was the moment, when broken terrain and weather reduced the Americans to fighting blind. But something impossible was happening. American Sherman tanks, separated by miles of frozen forest, were coordinating counterattacks with precision that defied every principle of armored warfare. No motorcycle couriers racing between units. No signal flags visible through the blizzard. No field telephones strung across battlefields the Germans controlled. Yet American tank platoons from different companies, different battalions, even different divisions, converged on German spearheads with timing that seemed supernatural. Each Sherman crew knew exactly where friendly forces positioned, exactly where enemy armor threatened, exactly when artillery support would arrive. The Germans had superior tanks. They had tactical surprise. They had numerical advantage in the opening hours. What they didn't have was the invisible network connecting every American armored vehicle on the battlefield. While Panther commanders shouted orders that crews in adjacent tanks couldn't hear over engine noise, American tankers spoke clearly to comrades 10 miles away. While German forces fragmented into isolated combat groups when command vehicles fell, American units maintained coordination regardless of which tank led. The technological revolution that would decide the Battle of the Bulge, and ultimately World War II itself, rode invisibly through the Ardennes in equipment the Germans fundamentally misunderstood. 25 watts of frequency-modulated radio transmission. Crystal-controlled precision. Noise-canceling clarity. Installed in every single American medium tank since 1942. This was the SCR-508 system. And by December 1944, it had already rewritten the rules of armored combat, the Germans just didn't know it yet. The transformation began not in combat, but in a Chicago factory. July 1941. 14 months before America entered the war, Army Signal Corps engineers at Galvin Manufacturing Company, later known as Motorola, solved a problem that would prove more decisive than any improvement in tank armor or firepower. The challenge was electromagnetic. Existing radio systems used amplitude modulation, the same technology as civilian broadcast stations. AM signals carried voice communication by varying the strength of radio waves. This made them vulnerable to interference. Every spark plug, every electrical motor, every lightning strike generated static that overwhelmed weak signals. In a tank, surrounded by diesel engines and electrical systems, AM radios produced more noise than communication. Engineer Daniel Noble proposed applying Edwin Armstrong's frequency modulation technology to military vehicles. FM radios varied the frequency of radio waves rather than amplitude, making them immune to most electrical interference. The breakthrough came when Henryk Magnuski, Motorola's principal RF engineer, designed a ruggedized FM system that could survive tank combat environments. The result was the SCR-508, 181 pounds of electronics that would transform American armor into history's first networked fighting force. The BC-604 transmitter generated 25 watts of output power across 10 crystal-controlled frequencies in the 20 to 28 MHz range. The dual BC-603 receivers allowed simultaneous monitoring of command and tactical nets. The BC-606 intercom integrated all 5 crew members into the communication system. Every component was engineered to military specifications that made civilian radio equipment look fragile by comparison. Shock-mounting protected vacuum tubes from main gun recoil. Sealed enclosures kept out dust, mud, and moisture. Dynamotor power supplies filtered electrical noise from vehicle systems. By November 1942, when the first Shermans landed in North Africa during Operation Torch, every tank carried this sophisticated system as standard equipment. The contrast with German armor was stark. A typical German tank platoon of 5 vehicles included 1 or 2 tanks with FUG-5 transceivers capable of both transmission and reception. The remaining tanks carried FUG-2 receivers only, they could hear orders but couldn't respond or report. German doctrine accepted this limitation because their pre-war industrial planning hadn't anticipated the radio production demands of mechanized warfare. Each FUG-5 used AM technology operating at 10 watts in the 27 to 33 MHz band. Maximum range when vehicles were stationary, 3 kilometers. When moving across rough terrain, perhaps 500 meters of scratchy, interference-filled communication. German tank commanders learned to fight within visual range of subordinate vehicles because radio communication beyond that was unreliable. When someone destroyed the platoon leader's tank, easily identified by its multiple antennas, the entire unit often lost coordination. Subordinate tanks with receivers only had no way to communicate with each other or call for help. February 1943. Kasserine Pass, Tunisia. The first major American armored engagement against experienced German forces should have been a disaster. In many ways it was. American units suffered tactical defeats and heavy losses. But German after-action reports noted something disturbing. American coordination seemed unaffected by broken terrain and unit separation. 5th Panzer Army intelligence officers intercepted American radio transmissions and reported exceptional clarity at ranges where German equipment produced only static. One intelligence summary stated, "Enemy demonstrates radio discipline and coordination suggesting extensive training." The German analysts completely missed the technological foundation. They assumed American radio performance resulted from superior training and procedures, not understanding that FM technology was providing capabilities German equipment physically couldn't match. This analytical failure, attributing American advantages to training rather than technology, would persist throughout the war, preventing German forces from developing effective countermeasures. By September 1943, American armor entered Italy, where mountainous terrain should have negated any radio advantage. Ridgelines blocked line-of-sight communication. Valleys created multipath interference. German commanders expected their tactical doctrine, designed for close-quarters tank fighting, would prove superior. Instead, FM technology shined in the environment that defeated AM systems. SCR-508 radios handled the complex propagation of mountain terrain far better than frequency-drifting German sets. American tank platoons separated by entire ridgelines coordinated attacks with precision German doctrine said required visual contact. Major Robert Garrison, communications officer with the 4th Armored Division's headquarters company, began developing tactics that exploited this advantage. Garrison had been a civilian radio engineer in Detroit before the war. He understood the SCR-508's capabilities better than most armored officers, and he saw possibilities the manuals hadn't anticipated. Traditional doctrine used radios primarily for command and control, orders flowing down from headquarters to subordinate units. Garrison proposed using them for lateral coordination, tank platoons sharing information directly with adjacent units, tank destroyers, artillery observers, and air support controllers. The concept was revolutionary. It required tankers to think of their radios not as telephones connecting them to a boss, but as networks connecting them to every friendly asset within range. 4th Armored Division Commander Major General John Wood authorized Garrison to experiment with network coordination tactics during training exercises in England before D-Day. The results were extraordinary. Tank platoons that had never worked together before could coordinate complex maneuvers within minutes of establishing radio contact. Artillery support that traditionally required 15 to 30 minutes from target identification to shells landing was reduced to 3 to 5 minutes. Infantry could guide tanks to enemy positions the armor crews couldn't see. June 6, 1944. Normandy. As Shermans rolled off landing craft, their SCR-508 radios maintained contact with naval fire support observers offshore, enabling precision fires that German forces couldn't coordinate with their separated armor, infantry, and artillery commands. But the Bocage hedgerow country revealed a critical gap. Tank radios operated on 20 to 28 MHz. Infantry radios, the SCR-300 backpack set, operated on 40 to 48 MHz. The frequencies were incompatible. Tankers and infantrymen fighting 50 yards apart couldn't communicate directly. In the hedgerows, where German infantry with Panzerfaust anti-tank weapons stalked American armor through dense vegetation, this gap proved deadly. Tank crews, buttoned up with hatches closed for protection, couldn't hear infantry warnings about nearby threats. Infantrymen couldn't direct tanks to enemy positions they could see, but the armor crews couldn't. The vulnerability cost lives. Major Garrison saw the problem and implemented a characteristically simple solution. His maintenance crews welded .50 caliber ammunition boxes to tank hulls and installed EE-8 field telephones inside, wired directly to the tank intercom system. Infantry could pick up the external phone and speak directly to the tank crew. Within 3 weeks, 4th Armored Division's entire tank force carried these jury-rigged systems. Other divisions copied the innovation. By late July, tank infantry coordination in American forces had been transformed by a field modification that cost perhaps $5 per tank. German forces developed no equivalent system. Their communication poverty extended beyond tank-to-tank coordination to fundamental gaps in combined arms cooperation. July 25, 1944. Operation Cobra, the breakout from Normandy. Major Garrison's network coordination tactics scaled from experimental concepts to army-level doctrine. General Wood's 4th Armored Division, spearheading Patton's 3rd Army advance, coordinated over 200 Sherman tanks through radio networks that enabled unprecedented battlefield control. Every tank commander could hear General Wood's command net. Every platoon maintained contact with adjacent platoons. Every company commander monitored both his unit frequency and the battalion command net. Artillery forward observers in Sherman command tanks called fires directly. Tank destroyer battalions received targeting information from regular tank companies that spotted enemy armor. The result was an organism, hundreds of armored vehicles acting with collective awareness no previous military force had achieved. German defenders from Panzer Lehr Division faced an enemy that seemed omniscient. Report enemy tanks to the east, and American artillery struck before German forces could maneuver. Attempt to flank American positions, and reserves appeared to block the move. Try to mass armor for a decisive counterattack, and American fighter bombers, guided by radio-equipped forward air controllers with tank units, destroyed the formation before it assembled. Panzer Lehr, once Germany's elite armored training division, had been reduced to communication desperation. Most tanks operated without radios at all. The few functioning FUG-5 sets suffered interference and range limitations that prevented effective coordination in the fluid battle. Tank platoons fought as isolated groups rather than coordinated units. The irony was profound and tragic. Heinz Guderian, architect of German armored doctrine, had built his blitzkrieg concepts on radio communication. His 1937 book, Achtung Panzer, emphasized communication as essential to armored operations. Guderian insisted on radio equipment for tanks since the 1920s, understanding that rapid advances required instantaneous coordination. But by 1943, German industrial production couldn't provide the radios Guderian's own doctrine demanded. In 1943 alone, Germany manufactured approximately 5,700 medium and heavy tanks but fewer than 2,000 FUG-5 transceivers. Many radios went to assault guns and command vehicles, leaving regular panzer units desperately short. Production priorities favored building more tanks over equipping existing tanks with adequate communications, a strategic error that battlefield results couldn't overturn because High Command never recognized the problem's severity. September 1944. The Battle of Aricourt, in northeastern France, provided mathematical proof of American radio superiority. 4th Armored Division, with Garrison's network tactics fully implemented, faced multiple German panzer brigades equipped with Panther and Tiger tanks that were individually superior to Sherman's in armor protection and firepower. On paper, the Germans had every advantage. In practice, American coordination proved decisive. Every Sherman could report enemy positions instantly. Tank destroyers, equipped with compatible radios, received targeting information from tanks 5 miles away. Artillery observers called devastating barrages within minutes of target identification. Major Garrison, monitoring the division command net from headquarters, coordinated fires and maneuvers across 50 square miles of battlefield. Over 3 weeks of combat, 4th Armored destroyed 281 German armored vehicles while losing only 41 Shermans, a 7-to-1 kill ratio that defied technical specifications. American tank crews weren't better trained than German veterans. American tanks weren't superior platforms. But the American system, tanks functioning as network nodes rather than isolated vehicles, was overwhelmingly superior to anything German forces could field. German intelligence never understood. A captured September 1944 intelligence assessment stated, American forces demonstrate effective radio discipline and rapid coordination. This appears to result from extensive communications training and standardized procedures. The report attributed American success to training and doctrine, completely missing that FM technology was providing capabilities German AM equipment couldn't physically replicate. German tactics never adapted. They continued targeting supposed command tanks based on antenna configurations, not realizing every Sherman could coordinate responses. They planned ambushes assuming American coordination would break down when units separated, not understanding radio contact maintained cohesion regardless of visual contact. The analytical failure extended to the highest levels. Even as German forces lost engagement after engagement to American coordination advantages, Wehrmacht leadership never prioritized solving the communication gap. Resources went to building better tanks, bigger guns, thicker armor, more powerful engines, while the actual decisive factor, the electromagnetic spectrum, remained conceded to American superiority. December 16, 1944. The Ardennes offensive began. Hitler's last major attack in the West depended on surprise, speed, and winter weather that would ground Allied aircraft. In the opening hours, German forces achieved tactical surprise and rapid penetration. American units were scattered and isolated by the sudden onslaught. This should have been the moment when German tactical doctrine triumphed, close-range combat in broken terrain where superior tank quality mattered most. But Major Garrison's network lived. From 4th Armored Division headquarters in Luxembourg, Garrison monitored desperate radio calls from surrounded American units. Within hours of the offensive's start, he had comprehensive understanding of German penetrations because every American tank in contact was reporting through the radio network. Traditional military intelligence, maps updated by courier, phone reports from isolated units, reconnaissance delayed by weather, would have taken days to assemble this picture. Garrison had it in real time, radio to 3rd Army headquarters where Patton made the decision that would define the battle, immediately cease the eastward offensive into Germany and pivot the entire 3rd Army 90 degrees north to relieve Bastogne. The maneuver was considered impossible. Military doctrine said armies couldn't change direction that rapidly. Logistics, coordination, and command and control requirements made it theoretically unfeasible. Patton did it in 48 hours. How? Radio coordination. Orders reached every unit simultaneously. Quartermasters redirected supply columns through radio networks. Artillery battalions displaced to new positions while maintaining fire support through radio contact with forward observers. Tank battalions from different divisions integrated seamlessly because they all spoke the same electromagnetic language. German forces in the Ardennes fought increasingly isolated battles. Their communication systems, dependent on field telephone lines, broke down as American forces cut wires and disrupted headquarters. Radio communication, never robust in German armor forces, collapsed under the chaos of fluid combat. By December 26, when 4th Armored's lead elements broke through to Bastogne, the battle's outcome was no longer in doubt. American forces had turned tactical surprise into strategic defeat through coordination the Germans couldn't match. Major Garrison's network had enabled the impossible, an entire army pivoting in winter combat faster than the enemy could react. March 1945. As American forces reached the Rhine, their communication superiority reached operational perfection. The capture of the Ludendorff Bridge at Remagen demonstrated speed that German command structure couldn't comprehend. When 9th Armored Division scouts discovered the bridge intact, radio reports reached 1st Army headquarters within 5 minutes. Within an hour, orders redirecting divisions across the entire front flowed through radio networks. Within 6 hours, American tanks were pouring across the bridge in numbers that guaranteed the bridgehead survival. German forces, dependent on telephone communications that American artillery systematically destroyed, couldn't organize effective counterattacks. Corps-level coordination that should have taken days to arrange never materialized because German headquarters couldn't communicate with subordinate units or each other. By the time German High Command understood the disaster's scope, American engineers had constructed additional bridges and the bridgehead was impregnable. April 1945. The encirclement of the Ruhr pocket demonstrated the culmination of American radio superiority. 1st Army advancing from Remagen and 9th Army driving from the north coordinated a complex double envelopment entirely through radio communications. Inside the pocket, 325,000 German troops, an entire army group, found themselves trapped partly because German communications had collapsed. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication centers. Headquarters lost contact with subordinate commands. Field commanders couldn't coordinate with adjacent units. What remained of German radio networks was overwhelmed by the scale of the disaster. Field Marshal Walter Model's final messages before communication failure captured German desperation: no contact with adjacent corps. No communication with Army Group headquarters. Local fighting continues but operational coordination impossible. Model committed suicide on April 21 rather than surrender. The 325,000 German troops in the Ruhr yielded in fragments, isolated units surrendering when they ran out of ammunition and hope. American radio superiority affected not just tactical outcomes but the psychological experience of armored warfare. American tank crews fought with profound assurance: they were never alone. Even when physically isolated by terrain or enemy action, they remained connected through radio waves that linked them to an invisible brotherhood. German tank crews experienced the opposite: profound isolation. Unable to communicate beyond visual range, they fought individual battles within larger engagements they couldn't comprehend or affect. The psychological burden of this isolation, of fighting blind while the enemy seemed omniscient, eroded German effectiveness as surely as material losses. Otto Carius, one of Germany's most successful tank commanders, wrote after the war about the challenges of limited communication, though he focused on tactical adaptations rather than acknowledging the fundamental gap. German tankers learned to fight without the tools their own doctrine said were essential, because learning was the only alternative to dying. After Germany's surrender, American technical intelligence teams evaluated captured equipment with systematic thoroughness. Technical Intelligence Report 176 concluded that German tank communications were approximately 5 years behind American systems in fundamental technology. The absence of frequency modulation, limited radio distribution, poor electrical noise suppression, and unstable frequency control created vulnerabilities that no tactical doctrine could overcome. Soviet evaluators, given access to both German and American equipment through Lend-Lease, reached similar conclusions and chose to base post-war radio development on American FM designs rather than German AM systems. The numbers told the story: American production couldn't be matched. SCR-508, 528, and 538 radio sets, 50,000 units produced from 1942 to 1945. Sherman tanks manufactured, 49,324. Deployment rate, 100%, every tank carried full communication suite. Transmission power, 25 watts. Range while moving, 7 miles. Range stationary, 10 to 15 miles. Frequency stability, crystal controlled, plus or minus 0.01%. German production revealed the crisis. FUG-5 transceivers, approximately 6,000 produced. Medium and heavy tanks, approximately 12,000 manufactured. Full transceiver deployment, approximately 20% of vehicles. Transmission power, 10 watts. Range while moving, 1/2 to 1 mile. Range stationary, 2 to 3 miles. Frequency stability, variable capacitor tuning, plus or minus 1% drift. The radio superiority of American armor established principles governing warfare today. Modern main battle tanks carry communication systems tracing direct lineage to SCR-508 concepts, universal deployment, reliable coordination, network awareness. The German Bundeswehr, rebuilt in the 1950s, prioritized communications based on World War II lessons. A Bundeswehr training manual explicitly states, "The defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority." Modern conflicts validate this lesson repeatedly. The 1991 Gulf War saw coalition forces with superior communications destroy Iraqi forces equipped with individually superior Soviet-designed tanks but inferior radios. The 2003 invasion of Iraq again demonstrated that network-centric forces defeat platform-centric forces regardless of individual vehicle quality. Major Robert Garrison returned to Detroit in late 1945 and resumed civilian radio engineering. He never wrote about his wartime innovations and rarely spoke of them. The networks he pioneered became so fundamental to American military doctrine that his specific contributions disappeared into institutional knowledge. He died in 1983, his obituary mentioning military service without detail. The SCR-508 radio sets were scrapped by the thousands as surplus after the war, their strategic importance unrecognized by a public that celebrated tank crews and generals but never understood the invisible technology that made victory possible. Yet the revolution remained. Every time a modern tank crew coordinates through digital networks, they're using principles born in 1942. Every time military forces achieve what German doctrine said was impossible, fighting as a unified organism across vast distances, they're validating the lesson American armor learned in the snows of the Ardennes. Germany pioneered radio-armored warfare. Heinz Guderian built doctrines that revolutionized combat. But industrial priorities and analytical failures meant German forces fought World War II with communication technology inferior to the doctrine that required it. America perfected what Germany pioneered. And in perfecting it, America created the first networked fighting force, 49,324 Sherman tanks that weren't just armored vehicles but nodes in an electromagnetic web connecting crews who fought as one. The battle reports recorded American victories from Kasserine to the Ruhr. But they never captured the real reason, invisible radio waves proving more powerful than armor-piercing shells. Connection defeating isolation. Information dominance defeating platform superiority. The network defeating the individual, in principle that governs warfare still.